using like iterations to generate like bit masks. So bit masks are cool because they generate all possible combinations of an array. So for example, if I wanted to go ahead and make 0, 0, 0, 0, 0, 1, all the way to 1, 1, 1, what you can do is this code below, and this code below is just saying, well, what kind of bits do you want? So there's 0 and 1 for bits, and then in this pool array, you're going to just duplicate this a bunch of times, like so. And then your result, it's a two-dimensional empty array, and then what will happen is from this line onwards, it's kind of where you see this tricky loop come in, and this tricky loop is quite nice because this generating function will allow you to basically generate, as many numbers as you want. In this case, a bit mask. All right, so in this case, for pool, so for each one of these, because I repeated it 4 times, so it's going to do this 4 times. The result is just going to be every element of result and then appended to every element that's in this current pool. In this case, your pool is 0 and 1. So you start with a completely empty array, so it just tacks on this 0 and 1 here. But the neat thing is that now in each iteration, you would multiply it by for x in result. So for x in result, this is length 2. So it will grow by how much? The number of results times the number of elements in result, in this case 2, times the number of elements in pool. So 2, 2, and then 2. So 4 becomes 18, and then 18 becomes 16, which makes sense. So this is cool, because then in the next iteration we have this 0, 1 to start with, and then for each of these zeros, I'm going to loop through this pool, and then I'll do 0, 1, and then for 1, I'll do 0, 1 as well, and then now for these, I'm also going to, for each one, append 0, 0 and 1 for each of these. So 0, 0 as a prefix twice, 0, 1, and 0, 1 as a prefix twice, and then you get the point. It kind of expands out, and then you get this nice bit mask here. However, this is a pretty cool, neat trick that's in the Python documentation, but during an interview, especially this syntax, it's not so great because it causes some friction with the interviewer, because it's a little hard to understand for one, for me anyway, and the interviewer isn't super, like if you're interviewing Python and the other guy's like more of a C++ guy, then these Python specific syntax might be a bit hard, but it's quite a nice line for your own programming purposes. So let's switch gears and do kind of the same thing. So it's not really switching gears. Well, let's say you have a problem, and I believe this problem was presented to me at a Microsoft on-site software interview I had back in 2011, 2012, I don't know. And this was to basically go ahead and print out all possible combinations of these cards. So like you can have J, Jack King, Jack 1, Jack 2, Jack 3, and then what you need to do is, like, if you need to iterate all possible iterations, what you just need to do is create a bit mask. And so you could do it in this way, and then for each of these you can say, well, if element 0 is 1, then I go ahead and index the 0th element, so on and so forth. What we're going to do is a little bit perhaps cleaner. So you can say width is length of x, and for I in range x, so 32, and 32 or 0 to minus 1, 0 to 31, which is actually what we want, because a bit mask is going to be a binary representation. So and then for j in range So basically what we're trying to do is for each number, we want to, for example, 10110, we want to be able to right shift it and then see if the last digit is a 1. So with, if I right shifted by j is gonna be odd, meaning the last bit is 1, then we go ahead and want to append this to the how do we, yeah, let's do this. Append this array, and then so for example, if the second one of this bit mask is 1, then we want to just go ahead and append the second index. So it's a j, and then so we do this, and let's actually just do string. It's a little bit more cleaner. Okay, and then so when you're done, then you can just do answer dot append your s and print answer. Let's see if this does anything. No. Yeah, so this is length of 5, so 2 to the 5 is 32. JK123. Okay. Fine. I'm just trying to see if I can have this be a little bit more readable. All right. Let me change this to ABC, because the mixture of letters and numbers are not quite right. So JK and then JK, so like 0, 1, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So now we've got all this, all these things, and then I could also say just for clarity, we can also look at the bit mask, right? So this is the bit mask representation of 13. So JAB is 1101, which is the case. And then the thing is nice, because if they ask a follow-on problem like, show me all the things with I only want to see all the different combinations with length 3, right? And perhaps it's a parameter, right? So maybe like parameter k equals 3, then you can just say, I only want to append this if the length I guess I don't append the answer anymore. But instead of appending the answer here, you can just say, I don't want to print this. If length isn't of s is not this parameter, then do this. Sorry, it is. So now you get all possible combinations or permutations with 3 bits, right? So if I were to say, give me all combinations with, pairwise 2, then you can get, JK, JA, JB, and then, JK, JA, KA, JB, KB, and AB, and JC, KC. So, yeah, you would see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which I believe 10 is 5, choose 2. is going to be 5 times 4 divided by 2. Yeah. So yeah, so it's correct here. And then you can, like whatever the interviewer throws at you, because you now have this bit mask, you can just throw a filter here whenever you'd like to be able to do, things against the general case, right? If they're like, oh, like I want you to always, sort this, then you could probably just do sorted something. Can you sort like this? Yeah. So yeah, you can always just throw a filter on here in your answer, because you'll basically output all possibilities, and now any query that your interview asks you can be translated to an actual programmatic query where you just filter out certain things. And it's pretty neat, because I think I had a pretty similar question where it's just basically output all different permutations. I did like a DFS thing, and a DFS is a bit hard. It looks more like this, except recursive. So it's hard because then you also need to make sure that you're not looping over the same elements, right? So you actually need to create a bit mask and then filter out for the thing in that case, and that's pretty neat. But anyway, yeah, that's it for this video. Just a nice, simple kind of like technique practice and start understanding these patterns, because if you know how to generate bit masks, you can answer a fair amount of permutation questions, or at least use that in the toolbox to know how to deal with permutations, and then permutations are not going to be as daunting. So yeah, I hope that helps, and I will see you in the next one.